Welcome everyone. Today we're going to be talking about the area of circles, and then after that we're going to be talking about the area of sectors. Have a look at the learning intentions now, but also at the end of the lesson, and see if you've been able to achieve all of these aims. Okay, let's go ahead and actually find the area of a circle now. The area of a circle formula is actually pretty cool because it's going to use our friend pi that we learned about in a previous lesson. The area formula for a circle is pi r squared. Now, this is very different to when we did the circumference, which is 2 pi r. I know it looks similar, but squaring r is very different to multiplying it by 2. So these are two different formulae. So that's why it's so important to be careful that you read the question. It's asking about the area, but also that you write A equals at the start, because that will tell your teacher what you're doing, but also help prompt your brain about what kind of formula that you want to use. For these examples, we want to find the area of the following in terms of pi, practicing that skill that we did in a previous lesson, but also correct to 2 decimal places. So let's have a go at that. We're going to observe our circle. Here we have a circle that has, I wonder what that is. That's a radius of 77 millimeters. So you might like to label that as R. And we know that area, whoops, that one went a bit funny. Let's have another go. We know that area equals pi r squared. So remember we talked about doing formula, substitute, answer with units? Same deal here. Now we're going to substitute. We're going to put in pi times the radius is 77 squared. Now, if we're doing this in terms of pi, we need to find out what 77 squared is. You could do that by hand, or you can do it on your calculator. So that's going to be pi times 77 squared is the same as 5,929 pi. Let's put that down. Awesome. If we wanted to actually figure out what that was, correct 2 decimal places, there's a couple of things that you could do next. You could just hit times on your calculator and it will remember that this answer here is the previous number that you found, 5,929. You could also type that in again, but if it's already in your calculator, why not use it? Let's use Shift Pi. Oh, and that tells us it's going to be 18,626. And then rounding it to 2 decimal places, 0.50. We've done our formula, substitute, and answer, but we haven't put units in. Given that the radius was in millimeters and we're doing an area now, it's going to be millimeters squared. Awesome. So let's also put a millimeters squared here because that technically was the answer to in terms of pi. And then this was the answer to 2 decimal places. Okay, I have tried to trick you with the second circle here. Can you see what I've tried to do? Hopefully you recognize that what I've given you there is actually a diameter. So the radius is going to be half of this, so 8 centimeters. When we did circumference, we had a formula for when we had the radius and a formula for when we had the diameter. But in area, not the case. Area is pi r squared. We'll always need the radius. So this is a pretty typical way you'll try to be tricked. We've figured that out. Excellent. Now we're going to do the same thing. Area equals pi r squared. Now we'll substitute. Pi times 8 squared. Now this one, we don't even need a calculator to answer this in terms of pi. That's going to be 64 pi. So we've answered that portion of the question. Very nice. So now let's actually find out what 64 pi is on our calculators. And that's going to be to 2 decimal places, 201.06. Our units now, centimeters squared. When we're looking at sectors, these are actually fractions of circles. And I think it would be really good if we wrote down the definition of a sector. So a sector is a portion. You could also write a fraction. So I'm going to write fraction of a circle enclosed by 2 radii and an arc. Very nice. So here you can see our 2 radii, and we had a beautiful arc here. Same thing, 2 radii, and we had our arc. To help us find the formula for the area of some sectors, let's have a look at some now. So here we have this nice sector. This is one of our special sectors that actually has a name. Perhaps you remember it's called the quadrant, or a quadrant, I should say. Now we said a quadrant was a quarter of a circle. And that's important here because we're going to be talking about fractions of whole circles. How do we know it was a quarter for sure? Well, we knew when we did the angle in our quadrant, when it's a box, we know it's 90 degrees. Well, when we divide that by a full revolution for a circle, that was 360. Now, I know that 90 goes into 90 once and it goes into 360 4 times. In actual fact, I would have cancelled off the zeros and said 9 goes into 9 once and 9 goes into 36 4 times. But same thing. So that means it's a quarter of a circle. Interesting. Okay, so let's look at this next shape here. We've got another sector, and I notice it's 90 degrees. This is the angle outside of our sector, but that's not the angle we want. We want this angle inside of it. So that angle there, we're able to find it by doing 360 minus 90, which will give us 270 degrees. So we've tried to trick you here, but you can see this angle is 270 degrees inside of our segment. Well, you might have an idea of how much of a circle this is, but let's just double check. So the angle in our sector is 270 degrees divided by 360. Let's cancel off those zeros like I spoke about before. And what's a number that goes into both 27 and 36? Well, I know 9 goes into 27 3 times, and 9 goes into 36 4 times. So that means this is 3/4 of a circle. Okay, cool. What about the next shape? If we had 60 degrees here, what do you think we're going to do? Hopefully you thought, well, 60 divided by 360 will give me what fraction of a circle this is. Let's cancel off those zeros. And 6 goes into 6 once, and 36 6 times. So this is 1/6 of a circle. Hopefully you're seeing the next example going, oh yeah, I know, when that's 180 degrees, 180 over 360, well, that just gives me a half. Really nice. So, if I had this unknown angle here, remember when we don't know what the angle is, or we just need a placeholder, this is theta. That's our Greek letter friend. How much of a circle is shown here? Well, before, we always put the angle on top of 360. Our angle now is theta, so let's put that on top. Theta. Like we said, 360. To find these areas, what do you think we would do? It's going to be the area equals the fraction of the circle times the total area of the circle, which would be pi r squared. So for a quadrant, area would be a quarter times pi r squared. For this one, area would be 3/4 pi r squared. For this one, area would be 1/6 times pi r squared. Semicircle, I reckon we can do that one easily. Area equals a half times pi r squared, because remember, multiplying by a half is just the same as dividing by 2. So that means for any sector we find in the world, all we need to do is whatever that angle is, divided by 360, and like we did before, we'll probably cancel that nice fraction down, if we can, and then multiply it by pi r squared. So going back to what we had before, that means the area of a sector is going to equal the angle over 360 times pi r squared. So just for a couple of special sectors, we said a semicircle, well that was A was going to be a half times pi r squared. There's an invisible time sign in between the half and the pi r squared. And the area of a quadrant, well we know that 90 over 360 cancelled down to a quarter times pi r squared. So we've got a couple of sectors here, and in fact questions 1 and 2 are all about sectors. We've got some special sectors in question 2 that have names, but they're all sectors. So area equals theta over 360 pi r squared. Now that theta, the angle here, that's 60 degrees. So 60 over 360 pi times, let's put in our timeses because we're substituting, and the value of r was 7, so times 7 squared. If you had gone straight to 1 over 6 times pi times 7 squared, that's perfectly fine with me. Now we need to do this to 2 decimal places. So let's put this into our calculator. 1 over 6 times pi times 7 squared. Lovely. So that's going to be 25.66. What units would this be? Centimetres squared. Let's jump into the next example. We've got another sector, but I've tried to trick you. Can you see how I might have done that? Hopefully you recognise, that 70 is not inside the sector. I actually want this angle here. How will we find this angle? Well, let's call that angle theta. Remember, when we don't know an angle, we call it theta, or it just stands for an angle, really. We need the angle in a whole circle, which will be 360 minus 70, and that's going to be 290 degrees. So when we do our area of a sector, theta over 360 times pi r squared, theta is 290 over 360. Now we're doing our substitute, so we'll put in our times. Pi times, what was the radius of this circle? It was 5. Just looking at this fraction, we could cancel that down to 29 over 36, but 29 I think is a prime number, so we can't really cancel it down anymore, which is a little bit yucky, but that's okay. We can just pop it into the calculator now. So you could put in 29 over 36, or you could have done 290 over 360. We've got times pi times 5 squared. That's going to be 63.27. And our units now are metres squared. Okay, with these next two shapes, I really don't mind if you went straight into writing the formula like this. For this one, area is going to be, we know that that's 180 and it's half a circle, so you could just do half. Pi r squared, that's fine with me. A half times pi times, what's the radius? This 4.5 metres is the diameter. The radius is going to be half of that. If you did it mentally, half of 4 is 2, half of 0.5 is 2.5, and that's all in metres. Nearly got tricked there, so 2.25 squared. Putting that into our calculator, half times pi times 2.25, all squared. And we want it to 2 decimal places again, so 7.95 metres squared. And for the last example of a sector, A equals, how much of a circle is this? This was a quarter. We know because there's a little right-angled sign there. So pi r squared, a quarter, nearly wrote a half there, a quarter times 27.3 squared. Now let's put that into our calculator and we get 585.35. And our units, centimetres squared. So when we're doing areas of sectors, remember we're doing the area inside of the shape. If you've been sitting there wondering why we haven't added on the flat bits to lots of the radius, it's because we're not doing the perimeter here. We're just thinking about how much area is taken up or how much two-dimensional space is taken up by this shape. Let's have a look at some of these areas now. We're going to go through 3A, B and C together, and part D is a challenge that I'm going to leave for you to do. And we can talk about it next lesson. So let's find the area of the shaded region in these shapes, and we're doing to 2 decimal places again. Okay, let's identify what we've got in this first shape here. I definitely see that we've got a circle that's been cut out because this region is not shaded here at all. So no shading in this region. But what kind of shape is this? Well, I know that that's the center of my circle and this is the radius. If I put another radius here, that would also be 6 centimetres. So it means this total length is 6 centimetres. Oops, no, not 6 centimetres, it's 12 centimetres. That was funny, because it's 2 lots of the radius, the diameter. The diameter of the circle is going to be the same in the other direction. So this length here is also 12 centimeters. So it looks like we've got, for our area total, we're going to do the area of, this is a square because its side lengths are the same, minus the area of a circle. What I've written down here, these are called subscripts. And these are just labels that we put. So that's just telling us the area of the square minus the area of the circle, just because we can't be bothered writing the whole thing. Let's put in our formula now. So the area of a square is length squared, minus the area of a circle is pi r squared. The length squared is going to be 12 squared, minus the area of a circle is going to be pi times that radius was 6 squared. Now, because we want it to 2 decimal places, let's get our calculator up. Okay, to 2 decimal places, that's going to be 30.90. And what units do we have here? Centimeters squared. Nice. With this next shape here, that's a little bit odd. It looks like we've got a quarter of a circle, and it looks like we've got a big total circle, a quarter of that, minus a smaller quarter of a circle. So just to help you visualize, it's like we've got a big circle here, we've just got a quarter of it, and we just want to find this region. So what we're going to do is we're going to take, to do our total area, is we need to find the area of the big circle, and we only need a quarter of it. So let's change that to be a quarter of the big circle minus a quarter of the small circle here. And to do that, we're needing to do 1 on 4 pi. Now, because this is the big circle, let's do this. Let's do capital R squared. That's nice. And then minus a quarter pi, and let's do for the small quadrant, little r squared. That's a bit fun. So what's the radius of the small circle? Hopefully you can see that that's 3 centimeters. We're told that this length here is 2 centimeters. So what's the total radius of the big circle going to be? Well, hopefully you can see that that's going to be 3 plus 2, which is 5 centimeters. So that means we're going to do a quarter pi, well, let's put in our time signs, 5 squared minus a quarter times pi times 3 squared. Now, if you put this into your calculator and you got a negative answer, you probably accidentally mixed up your small circle and your big circle. Okay, to 2 decimal places, that's 12.57. And that's the units, centimeters squared. Okay, so we're going to have a look at C, and then part D is a challenge that I'm leaving for you. So I'm going to have a go at this one, and I'm just going to do it without saying any words. Let's see how you go with it. You might like to pause the video and have a go at it. Whew, that one was a bit fun. Finding that radius of the big circle, I had to be careful. I had to find the diameter first and then find the radius. That's what I found helpful. Okay, the next one's being left as a bit of a challenge for you, and we can have a look at that next lesson. See you.